So far this this unit, we have been studying quadratics and different ways that we can solve quadratic equations. If you remember from Math 1, we learned that we could solve quadratic equations by factoring, but then we learned that not all polynomials were factorable, and so we had the other option of using our calculators to find the x-intercepts. And if you remember, on the coordinate plane, if we have a parabola, which is the shape of a quadratic, that the x-intercepts would give us the solutions, the zeros, the x-intercepts of the function would give us the solutions. So we would always try to solve by factoring, and if it couldn't factor, then we would use the x-intercepts and graphing to help us solve quadratic equations. Well, what if we don't always have a graphing utility with us? I don't have Desmos. I don't have my graphing calculator. How are some other options for finding those solutions? And so that's what we're going to be working on the next couple of days. We've done one, which was solving by square roots, and we practiced getting those decimal answers, the ones that didn't come out nice and even. We said, when you can factor it, that's when you know that it's going to turn out to be a rational answer. The nice fractions or integers, numbers that are a little cleaner. And then when we solved by square roots, that's where we would get a lot of times the irrational. Sometimes they would come out rational, but usually we would end up with the irrational answers, those decimals that when we were using our calculators, it helped us find. Square roots also had a problem though, in that it was limited. We could only solve by square roots if it had x squared but no x. And so that posed a problem as well, because not all quadratics are missing that x term. A lot of them have x squared and x. So what if I can't factor? What if I can't solve by square roots? And what if I don't have my graphing calculator with me? We do still have options. And in fact, it's called the quadratic formula. Now, we're not actually going to be doing the whole quadratic formula right away. I want to talk about the beginning parts of the quadratic formula, but this is a big deal. This is kind of like one of the big 5 things that everybody remembers from high school mathematics, the quadratic formula. It is a big deal. And so we want to make sure that we really understand it. So what we're going to talk about today is just a part of the quadratic formula called discriminant. Discriminant. All right. The discriminant of a quadratic. Don't forget the basic generic form of the quadratic equation. Okay, important things when we are solving, always has to be equal to 0, right? So just like when we were solving by factoring, we've got to make sure that the equation is equal to 0. And when the equation is equal to 0, we have a coefficient of x squared. A is always the coefficient of x squared. B is always the coefficient of x, and then C is always the constant. And the discriminant of a quadratic equation is always b squared minus 4 times a times c. This is the discriminant. It's going to be equal to a number, one single number. And that discriminant tells us a lot about this equation. We can know a lot about the answers to this equation without actually having found the answers yet. This number, whatever it ends up being equal to, is going to tell us whether that quadratic is factorable, whether that quadratic is going to be able to be solved and get a rational answer or an irrational answer, or is it going to have one of those repeated answers, or is it not going to have a real answer at all? And so this is a very useful number, because when I do that first, I know a lot about what my answer is supposed to be. This helps me know if I've done things right. Any kind of clue that I can have, like, oh, I know I'm supposed to end up with 2 rational answers. And when I end up with 2 irrational answers, then I'm like, wait a minute, something's not right. I know I was supposed to have this. So this is what I can plug in to find the discriminant. You just end up doing a little bit of arithmetic. So for example, if I have 3x squared minus 5x plus 7 is equal to 0. A is equal to 3. B is equal to -5, signs do matter, and C is equal to 7. So if I wanted to find the discriminant, which is b squared minus 4ac, I would just have to plug these in. I will give you the warning If you try to type this in your calculator and you do not use parentheses in the correct way, meaning that you put -5 in the parentheses and the square outside of the parentheses, if you just type in -5 squared, you are going to get a wrong answer. This has to be in parentheses. I just get in the habit of always putting B, A, and C in parentheses, regardless of whether they're positive or negative, and that way I'm in the habit of always doing it that way, and I don't have to worry about making a mistake. So when I plug this in and I figure out that this is 25 minus 84, and then I end up with -59. -59. This number is called the discriminant. Any problem where they ask you to find the discriminant, this is what they're asking you for. They do want it to be equal to a number. It's just a little quick formula, b squared minus 4ac, and it's going to give me a number. Now, what's the point of having that number? Well, for starters, we are going to actually use that number. It is a part of the quadratic formula. So we're going to use it to help us solve the equation. However, it's a good first step in solving the equation because once I find this number, it tells me a lot about the answers. And so sometimes I actually stop after this point because sometimes quadratics do not have a real solution. And so there's no point in me going on with the rest of the formula if it's not going to have an answer. And so we always want to find the discriminant first because it kind of tells us what is the answer going to be. So there's some information that you need to know about discriminants and what they tell us about the types of answers that our quadratic is going to be. Now, things to remember. Quadratics have two solutions. All right, two solutions for quadratics. I've pretty much made a big emphasis that we should always end up with two answers. That's why when we solve by square roots, we use plus or minus. When we solve by factoring, we end up with two answers. We've got to have two solutions. But we can know a lot about those solutions based on what we know about the discriminant. For starters, if the discriminant is greater than 0, just any number bigger than 0. If the discriminant is bigger than 0, then I know that I have two distinct different solutions. Two solutions, okay? If the discriminant is equal to 0, right? If the discriminant is equal to 0, then this is when we get that one repeated solution, because there's always two solutions. It's just that sometimes we get the same number twice. When we factor it and we get the same thing twice, we can get that one answer that is repeated. So that's one repeated solution if the discriminant is equal to 0. And if the discriminant is less than 0, if it's a negative number, this is basically, is it a positive number, is it 0, or is it a negative number? There's no real solution when the discriminant is less than 0. Next year, in Math 3, you will talk about an alternative to real solutions, but we aren't learning about those this year. So all you need to know is that if the discriminant is negative, there is no real solution. So we're either going to get two answers that are different from each other, two answers that are the same, one repeated solution, or there's no real solution. We also know a little bit more about these solutions if it is a positive number. If it is a positive number that is a perfect square, so let's say my discriminant ends up being a perfect square, like 25, or 100, or 49, or 64, 36, 16, any of the perfect squares. If that positive number is a perfect square, then I also know that I have two rational solutions. That means that I could have solved it by factoring. If my discriminant is a perfect square, this can be factored. It's a polynomial that can actually be factored. If it is not a perfect square, that means that it is an irrational solution. So not a perfect square, which is a whole lot more numbers than perfect squares. It's pretty much every other number except the perfect squares. If it is not a perfect square, then I have two irrational solutions. So it's going to be one of those with the square root in it that we end up having to reduce the radical. It's going to have a square root left in the answer. So finding the discriminant gives us a lot of information about what the solutions to this problem is going to be.